So we're looking at transformations of functions, and we want to do some examples. We're going to start with some more basic examples. We're going to go through several basic examples, then we'll look at complex examples where you have lots of transformations mixed together. But we'll start off with basic ones where there's just one transformation. So if you look at our function here, y equals x squared plus 3, the parent function here is y equals x squared. And then notice that that's the parent right there. And then the transformation that occurs is you have a plus 3 outside of the house, right? So anytime you have a plus outside of the house, it's going to be a vertical shift up. So it goes in the direction of the sign when it's outside of the house. So it's going to be, you're going to go up 3 afterwards. So use that chart that I gave in the previous video if you don't remember these. It's a good idea to remember these. So, I mean, since this is, a good idea to remember these. Okay, so I'm going to make a little graph. Start off with an x-axis and a y-axis. And I'm going to start off by graphing my parent. So if you go back to our section on the library of functions, that was section 2.4, section 2.4. To graph the parent, you know some key points are like negative 2, 4. So you square negative 2 and you get 4. You square negative 1, you get 1. You square 0, you get 0. You square 1, you get 1. You square 2, you get 4. You get those key points. And it makes kind of a U shape. We call this actually a parabola. Now, after you graph the parent, you're going to go up 3. That means I'm going to have to make marks all the way up to 7 maximum. I'm going to take the left end point, the green one, and go up 3. 1, 2, 3. I'm going to take this point here at negative 1, 1. I'm going to go up 3. 1, 2, 3. I'm going to take the point here at the origin. I'm going to go up 3. 1, 2, 3. I'm going to take the point here at 1, 1. I'm going to go up 3. 1, 2, 3. And I'm going to take the point here on the right end, which is at 2, 4. I'm going to go up 1, 2, 3. I'm going to connect these. This is y equals x squared plus 3. Okay, that's my final graph in red. I'll put a little box around that one to indicate that's the one, that's the final one. Okay, so the green one was y equals x squared, and the red one is y equals x squared plus 3. That's just one transformation. I'm just getting practice with single transformations before we do multiple. Okay, so next we're going to have y equals the cube root of x. And after the cube root of x, we're going to have minus 1. So you have the cube root function as your parent. So we'll graph that, and then that's the green here. And then we have a minus 1. Is that minus 1 inside of the radical? No, it's outside the radical. So that's going to be a outside of the house situation. And since it's a minus sign, we're going to go down 1. Yeah. So outside of the house is vertical motion. It goes in the direction of the sign. So it's down 1. Okay, so what we're going to do, we're going to make x-axis, y-axis. We're going to have 1, 2, 3, 4, 5, 6, 7, 8. Oops, I got that. It's plus 1. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. 1, 2, negative 1, negative 2. I'll rewrite this as negative 8. This is negative 1. Okay, so start off with the cube root function, the parent, and maybe remember you have when you plug in 0, the cube root of 0 is 0. When you plug in 1, the cube root of 1 is 1. When you plug in 8, the cube root of 8 is 2. So on the right side, you have this. And then you can plug in negative numbers. So the cube root of negative 1 is negative 1, and the cube root of negative 8 is negative 2, and on the left side, you have this. Now, we're going to go down 1. So basically, I need to make a marking here for negative 3. So we're going to take this left endpoint, which is at negative 8, negative 2, and move it down to negative 8, negative 3. We're going to take the point at negative 1, negative and move it down 1 to negative 1, negative 2. The inflection point, which is at the origin, is going to move down 1 to 0, negative 1. And the left side will look something like this. Okay. And then, let's see, on the right there at 1, 1, we're going to move it down 1 to 1, 0. And 8, 2 is going to move down to 8, 1. And we're going to have this on the right side. And as far as the green, I should have left that as like a dashed line or something. Let's make that a dashed line. I want to just keep the solid line for my final graph. So, yeah. So this is y equals the cube root of x, and then minus 1 outside of the house. I'm going to put a box around that one to indicate, hey, that's the final graph. That's the one that wants to be created. Okay, let's go into another example. Number 3. Y equals the absolute value of x plus 5. So the parent here is going to be the absolute value of x. And then inside of the house, we're going to have plus 5. So the parent here is the absolute value function. And we're going to, so this is inside of the house plus 5, so it's going to be a horizontal motion, and it goes in the opposite direction of the sign when it's inside of the house, so it's going to go left 5 rather than right 5, left 5. So I'm going to start with a y-axis and an x-axis. So the absolute value function, typically the absolute value function, y equals the absolute value of x. Let me actually write that, so that'd be y equals the absolute value of x. This was the cube root function. This was y equals the cube root of x. And this one here was y equals x squared. Okay, I'm not writing them down. Let's write them down. So we're focusing on this green function, graphing it. So when I plug in negative 2, the absolute value of negative 2 is 2. The absolute value of negative 1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. So you get this kind of V, the absolute value function. That's one of your parent functions from your library that you're supposed to be familiar with from section, what section was that? 2.4. Now what we're going to do, we're going to move everything left 5. So I need to make some markings on my x-axis to go left 5. So I'm going to go to negative 7, negative 3, negative 4, negative 5, negative 6, negative 7. Okay, so we're going to move, let's start at negative 2, positive 2, negative 2, 2. Move it left 5. 1, 2, 3, 4, 5. Let's take negative 1, positive 1, and move it left 5. 1, 2, 3, 4, 5. Let's take 0, 0, and move it left 5. 1, 2, 3, 4, 5. So it's at negative 5, 0. And let's take 1, 1, and move it left 5. 1, 2, 3, 4, 5. It's at negative 4, 1. And now as far as 2, 2, 2, 2, that's supposed to be like about here. Let's move it left 5. 1, 2, 3, 4, 5. It'll be at negative 3, 2. You graph that and you get this red thing here. It's red V. This is y equals absolute value of x plus 5. I'm going to put that in the box to indicate that's my final graph. Okay, let's do a number 4. It's going to be y equals parentheses x minus 2 cubed. So what's our parent here? It's y equals x cubed, the cubing function. Let's graph the cubing function. Not the cube root, but the cubing. Okay, I'm going to have to go by, I'm going to change my scaling. It's going to be by 1, 2, so 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. 1, 2, negative 1, negative 2. So scaling's a little different on the x-axis and the y-axis. So when you plot this out, you plug in 0. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. And on the right you have something like this. Negative 1 cubed is negative 1, and negative 2 cubed is negative 8. And on the left side you have something like this. Now notice that we have a minus 2 inside of the house. So that minus 2 inside of the house, it's inside of the house, so it's horizontal motion. It does the opposite of the sign. Opposite of the sign, so it's going to move right 2. It's going to move everything over to the right 2 units. So I got to go up to 4 on the x-axis. We're going to move everything right 2. So starting at, let's start at 0, 0. 0, 0 shifts right 2 to 2, 0. Let's go to 1, 1. 1, 1 shifts right 2 to 3, 1. Let's go to 2, 8. That shifts right 2 to 4, 8. So on the right side, I got something like this. And then on the, let's see, negative 1, we're going to shift it right 2 to 1, negative 1. And negative 2, negative 8, we're going to shift it right 2 to 0, negative 8. And on the left side, we're going to have this kind of thing. That's y equals parentheses x minus 2, close parentheses cubed. Box that in to indicate that's my final graph. Number 5. Guess I got y equals what do I have here? I can't even see. Minus 1 over x. So looking at the parent here, the parent is y equals 1 over x. It's called the reciprocal function. So we'll graph that one first. X-axis, y-axis. 1, 2, negative 1, negative 2, and then 1, 2, negative 1, negative 2. Now, if you remember, this one has a what's called a vertical asymptote here along the y-axis, and has a horizontal asymptote here at the x-axis. And the reciprocal function, if you plug in, let's plug in 2. So when you plug in 2, you reciprocate 2, you get 1/2. Let's plug in 1. You take the reciprocal of 1, you get 1. Let's plug in 1/2. You take the reciprocal of 1/2, you get 2. I'll make this one solid. Do I want to make it solid? No, I want to make it dotted. Let's make it dotted. Okay, then on the other side, I can plug in -2. The reciprocal of -2 is -1/2. So I have -2, -1/2 is a point. I plug in -1. The reciprocal of -1 is -1. So -1 is a point. And let's say I take -1/2 and reciprocate that. I get -2. So -1/2, -2 is a point. So I have a piece down here. Now what I'm going to do, I'm going to take this minus out in front, this red minus sign out in front. And what that's going to do, that minus is out in front of the house. So that is going to flip about the x-axis. It's going to flip it upside down. So it reflects about x-axis. So let's start at the point 1/2, 2. I'm going to flip that upside down. Same thing as multiplying it by -1. It's going to be 1/2 -2. Let's look at the point 1, -1. That's going to get flipped upside down, 1, -1. And let's take the point 2, 1/2 and flip it upside down to 2, -1/2. So basically the y-coordinates get multiplied by -1. So the red is new. Okay. Now let's take the left-hand side, that's down in the third quadrant, and let's flip all those points upside down about the x-axis. So I have this point here at -2, -1/2. That one. And I'm going to flip it upside down. It's going to go up to -2, +1/2. Then I'm going to take the point at -1, -1. It's going to go to -1, +1. I'm going to take the point at -1/2, -2, and multiply the -2 by -1. I get -2, +2. So I get this up here. So my graph now is in red. This is y equals -1/x. Has the same blue asymptotes, but the green flipped about the x-axis to the red. All right, number 6. How about y equals the square root of -x? So here the parent is y equals the square root of x. Right? Y equals the square root of x. That's a square root function. Let's graph the square root function. X-axis, y-axis, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And on the other side, -1, -2, -3, -4, -5, -6, -7, -8, -9. And on the y-axis, let's just do 1, 2, and 3. Let's do it like that. So remember, you can plug in 0. The square root of 0 is 0. I can plug in 1. The square root of 1 is 1. I can plug in 4. The square root of 4 is 2. I can plug in 9. The square root of 9 is 3. That's not a really good graph, is it? Let's redo this. We want to give ourselves plenty of space. I use the object eraser, and I want a lot of space here. Yeah, you need some space for this one. So I want to put this a little better with the scaling. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, -2, -3, -4, -5, -6, -7, -8, -9. No, that's wrong. Let me count. -1, -2, -3, -4, -5, -6, -7, that's it. Then we got here 0. No, that's not 0. That's 1, 2, 3. 0 would be there. Okay, y-axis. So again, I'm going to try this once again. So when you plug in 0, the square root of 0 is 0. When you plug in 1, the square root of 1 is 1. When you plug in 4, the square root of 4 is 2. When you plug in 9, the square root of 9 is 3. So you get this kind of shape for the square root function. Okay. Now what's this minus here do inside of the house that's in front of the x? So that minus there reflects, it's inside of the house, it reflects the graph about the y-axis. So I'm going to take the point at 0, 0, and it's going to stay fixed. The point at 1, 1, I'm going to reflect about the y-axis. I'm going to get 1, negative 1. Or sorry, negative 1, 1. Negative 1, 1. I'm going to take the point at 4, 2, and I'm going to reflect that about the y-axis. I'm going to get negative 4, 2. And the point at 9, 3, I'm going to reflect about the y-axis. I'm going to get negative 9, 3. This will be our graph. Oh, now just make it a solid line like it should be. Let's try this one more time. I guess that's good enough. Okay, so there it is. Y equals square root of minus x. I'll box that. So it's kind of a backward square root function, the red one. What else can we do? Some examples. Let's do a number 7. Okay, let's say we have y equals 2 times the cube root of x. So my parent here is going to be y equals the cube root of x. So let's do our cube root function. One, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, 5, 6, 7, negative 8. We'll have, let's go 1, 2. Negative 1, negative 2. X and y axis. So for my parent, I plug in 0, the square root of 0 is 0. When I plug in 1, cube root, this is cube root, not square root. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. So you have this on the right. And then when you plug in negative 1, the cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. So you have this on the left. And what we want to now focus on is this 2 out front, that red 2. What does that red 2 out front do? That is, it's out in front of the house multiplied, right? That is a stretch by a factor of 2. Stretches vertically by a factor of 2. So the idea here is we're not going to alter our x values. We're going to multiply all our y values by 2. So notice our largest y value is 2, so we're going to have to go up to 4. We're going to have to double that. And our smallest y value is negative 2. We're going to have to double that to negative 4. So if I take my point here on the far right, here at 8, 2, I'm going to double the y value. It's going to be 8, 4, so that'll be here. And then I'm going to go to my next y value at 1, 1. So notice 1, 1, at this point, right here. So we're going to double the y value. It'll be 1, 2. Okay, now at 0, 0, that's in the center. That's the inflection point. The y value is 0, so when you double 0, it stays 0. So you still have 0, 0. So on the right side, you have something like this. You just stretched out the green graph vertically. Okay, now let's go to this point called negative 1, negative 1, right there. Oops, I should make it in green. Negative 1, negative 1. So it should be green. Come on, green. Negative 1, negative 1. So you don't mess with the x value here. You're going to double the y value. So the y value is -1, so you're going to double that. It becomes -2. And then finally, we're going to take this point on the far left here at -8, -2. And we're not going to touch the x value. We're going to double the y value. So right now, the y value is at -2. We're going to double that. It's going to become -4. So it'll be -8, -4. So you double that, and you connect these. So here we are. This is y equals 2 times the cube root of x. So you got your cube root function stretched by a factor vertically of 2. Pretty cool, huh? All right, do some more examples. Yeah. That's 7. Let's do an 8. Y equals 1/2 x cubed. So first of all, you want to identify the parent. Y equals x cubed. Let's draw out the parent. X-axis and y-axis. -2, -1, 0, 1, and 2. And on the y, 1, 2, 3, 4, 5, 6, 7, 8. And on the y, -1, -2, -3, -4, -5, -6, -7, -8. Okay, so when I plug in 0, 0 cubed is 0. When I plug in 1, 1 cubed is 1. When I plug in 2, 2 cubed is 8. So on the right, I get this piece. Now when I cube -1, I get -1. When I cube -2, I get -8. So on the left side, I have these points in this graph. So now what do we have? We have this 1/2 out in front of the house. So that's out in front of the function, the 1/2 of the parent. So when you have it out front like that, that is multiplying the y values by 1/2. So it's going to be a vertical compression, vertical shrink by a factor of 1/2. So basically, I'm just going to multiply all my y values by 1/2 from the green. So I'm going to go to 2, 8, this point on the far right. And I'm going to multiply that y value of 8 by 1/2. So what's 1/2 times 8? Well, 1/2 of 8 is 4. So I'm going to put a point here at 2, 4. Then at the point 1, 1, we're going to multiply the y value of 1 by 1/2. So we'll get 1, 1/2 about here. Then at the origin, or the inflection point here in the center, 0, 0, you multiply 0 by 1/2, and you get a y value of 0. So that doesn't change. So on the right, we get this. So things kind of got compressed. The green graph got compressed. Okay, going to the left, when you take that point of -1, -1, you multiply the y value of -1, you get -1/2. So you still get x is -1, but y is now -1/2. And you're going to take -2, -8, that point here on the far left. You multiply -8, the y value, by 1/2. -8 times 1/2. Well, what's 1/2 of -8? It's -4. So that'll be right there, and you connect those. So that's it in red. Y equals 1/2 x cubed. Okay, maybe do a couple more. So just get more examples. Number 9, we're going to get y equals the cube root of 2x. So here, my parent is going to be the cube root of x. That's my parent. And inside of the house now. So that's not out in front of the house. That's inside of the house. That is a multiplication by 2, so that's going to be a horizontal compression by a factor of 1/2. Horizontal compression. So when it's inside of the house, it's a horizontal compression. And you multiply by the reciprocal of 2, which is a half, by 1/2. That means I'm going to multiply all my x-coordinates by 1/2 after I graph my, my big dude, my parent. So let's graph our parent first. Didn't turn out too well, did it? Let's try this one more time. One, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Negative 1, negative 2. Okay, so for the parent, we can plug in 0, 0 cubed is 0. We can plug in 1, 1 cubed is 1. We can plug in 8. I'm sorry, we're not cubing, we're cube rooting. The cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is 2. So for the parent, the right side looks like this. You can take the cube root of negative 1. So negative 1, I cube root that, I get negative 1. I cube root negative 8, and I get negative 2. So I got those points, and I connect those. So the left side looks like that. Okay. Now, what we're going to do, we're going to multiply the x-coordinates by 1/2. So on the far right, we have 8, 2, right? 8, 2. So we're going to multiply 2, 3, 4, 5, 6, 7. We're going to multiply the x value by 1/2. Not by 2, but by the reciprocal of 2, which is 1/2. So when I multiply the 8 by 1/2, I'm going to get 4. So I'll get 4, 2 for a point. So it's not going to be 8, 2 any longer. It's going to be 4, 2. Then I'm going to go to my next point, which is here at 1, 1. And I'm going to multiply the x-coordinate 1 by 1/2, and I'll get 1/2. So I'll get 1/2, 1. So that'll be back here. Now 0, 0, that's the origin, the center. The x value is 0, so I multiply 0 by 1/2 and I get 0. So I still have 0, 0. So the right side looks like this. So everything got compressed horizontally by a factor of 1/2. Okay, next I'm going to go to this point at negative 1, negative 1. So as an x value, negative 1, we're going to multiply that by 1/2, and we'll get negative 1/2 for our x value. So negative 1/2, negative 1 is our point. And then finally, we're going to go to negative 8, negative 2. The x value is negative 8. We're going to multiply negative 8 by 1/2. We're going to get negative 4. Negative 4 for an x value. So we get negative 4, negative 2 right there. So negative 8, negative 2 becomes negative 4, negative 2. And we're going to connect those points. So there is our horizontal compression. So we got the cube root of, rather than x, the cube root of 2x. I think I got one more here to do. I got number 10, which is y equals the square root of 1/2 x. You got the parent function is y equals the square root of x. And then after that, you got this 1/2 inside of the house. I'm going to make that red, 1/2. So because it's inside of the house and multiplied, it's going to be a horizontal. Horizontal, is it going to be a stretch or a compression? It's going to be a stretch because you look at the reciprocal factor. Horizontal stretch by, so I'm going to take 1/2 and take the reciprocal. So I take this number 1/2, the reciprocal 1/2 is 2. So horizontal stretch by 2. All right, so here we go. Graph in the parent. Let's see. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8. 0, negative 1, 2, 3, negative 4, negative 5, negative 6, negative 7, negative 8. I'm going to do 1, 2 here. negative 1, negative 2 here. Okay, I'll get rid of those marks. Okay, so when you're doing the square root function, right, you take the square root of 0, you get 0, square root of 1, you get 1, square root of 4, you get 2, and that should be a 2 right there. I'm not going to put any other points because it would go off page. So you get something like this for your square root function. Something like this. Now what I'm going to do, I'm going to multiply the x values by 2. So starting on the right with 4, 2, I multiply the 4 by 2, I'm going to get 8. So I'm going to get 8, 2. That's this green value on the right here. It gets multiplied. The 4 gets multiplied by 2, you get 8. Okay, now I'm going to go to 1, 1. So when I multiply the x value of 1, it's going to get doubled. So it becomes 2, right? So you get 2, 1. And then the origin, 0, 0, when you take the x value, multiply it by 2, the x value stays 0. So you're going to still have 0, 0. Now this is what we're going to have here. This will be y equals the square root of 1/2 x. So basically everything got stretched out horizontally by a factor of 2. All right, so these are all the